Dear student, today discuss about the circles. First of all, we discuss the chords and arcs. Let's see.
Equal chords of a circle subtend equal angles at the center. Consider a circle with chords PQ and RS. According to the theorem, if the lengths of chords PQ and RS are equal, then the angle subtended by PQ and RS, which are angles POQ and ROS, are also equal. Tap the button to understand this better with an example. Verify the theorem. Fill in the blanks in the derivation steps to prove the theorem. Fill in the blanks in the derivation steps to prove the theorem. Fill in the blanks in the derivation steps to prove the theorem. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Here, PQ and RS are chords subtending angles POQ and ROS respectively at the center. If angle POQ is equal to angle ROS, then their subtending chords PQ and RS are also equal. Tap the buttons to understand this better with more examples. Verify the theorem. Fill in the blanks in the derivation steps to prove the theorem. Fill in the blanks with the correct options. Fill in the blanks with the correct options. The perpendicular from the center of a circle to a chord bisects the chord. O is the center of a circle and PQ is a chord. If we drop a perpendicular from the center O onto the chord PQ at R, then OR will bisect the chord PQ. Therefore, PR is equal to RQ. Tap the button to understand this better with an example. Verify the theorem. Fill in the blanks in the derivation steps to prove the theorem. Fill in the blanks with the correct options. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Consider a circle with O as the center and chord PQ. If we draw a line segment OR from O such that it bisects the chord at R, that is, PR is equal to RQ, then OR is perpendicular to the chord PQ. Tap the button to understand this better with an example. Verify the theorem. Fill in the blanks in the derivation steps to prove the theorem. Fill in the blanks with the correct options. There is one and only one circle passing through any three non-collinear points. Let's consider three non-collinear points P, Q and R. From these non-collinear points, there can only be one point O, which is equidistant from all the 3 points. Therefore, there can only be one circle that can pass through these 3 points. For any triangle PQR, there is a unique circle that passes through all 3 vertices P, Q and R. This circle is known as the circumcircle of the triangle. The radius of the circumcircle is called the circumradius and the center is called the circumcenter. Verify the theorem. Fill in the blanks in the derivation steps to prove the theorem. Let us consider a line PQ and a point S that does not lie on this line. We can join the point S to points on PQ using infinite line segments. Of all these, the line segment SR, which is perpendicular to line PQ, is the shortest. This shortest line segment is taken as the distance between the point S and line PQ. Thus, the distance between line PQ and point S is equal to the length of line segment SR. Therefore, the distance of a point from a line is equal to the length of the perpendicular from the point to the line. Equal chords of a circle or of congruent circles are equidistant from the center or centers. Here, AB and CD are 2 equal chords of a circle. If we construct perpendiculars OM and ON from O on AB and CD respectively, these are the distances of the chords from the center. Thus, the distance OM of chord AB will be equal to the distance ON of chord CD. Tap the button to understand this better with an example. Verify the theorem. Fill Fill in the blanks with the correct options. Chords equidistant from the center of a circle are equal in length. Here, AB and CD are two chords of a circle with